Okay, so moving on, let's talk about production possibilities frontiers with only one factor of production. In essence, this is thinking about if before we thought about demand for apples and oranges, now we're going to think about the supply side, so how apples and oranges are produced. So suppose that there's only going to be one factor of production, that's going to be labor, and the production function of each good is going to be given by the following functions, where the marginal product of labor, or MPL, is just how much each worker can produce if we add an additional worker. Or sorry, it's how much one worker can produce, essentially. And then L apples and L oranges are going to be the amounts of labor used. You can think of this as the hours of work spent in the production of apples and oranges, or you can think about this in terms of the number of people. It doesn't really matter, but we're just going to think of those as the amount of labor that's going to be used in the production process. And so with one factor of production, everything here is linear, and so we just have that if we increase labor of apples or oranges by 1, we always have that the additional output that worker is going to produce, the marginal product of labor, is always going to be MPL apples. So the marginal product of labor here is going to be constant, and so we're going to call these linear production functions because they just have one good and it enters linearly. Okay, so now that we've introduced those production functions, let's spell out what the country's production possibilities frontier is going to look like. And so just to define that, a PPF, or production possibility frontier, is just going to be the bundle of goods that the country can produce if it uses all the available factors of production. So for one factor of production, labor, and 2 goods, apples and oranges, we have that workers can only work in 2 sectors. They can either work in apples or oranges. And suppose that we know that there's going to be full employment. That is, every person who's a worker in the country is either going to be working in apples or oranges. There's no such thing as unemployment here. Then we know that labor employed in apples plus labor employed in oranges must add up to L bar, or I'm going to call this just the total population of the country. Right? Okay. So this is just saying that since we have full employment, that if we add up the number of workers in each sector, then we'll have the full population. Okay, but now what we can do is I'm just going to divide this equation by the MPL of apples on both sides, or MPLA in this case. They cancel here. And so notice that L apples is equivalent to the number of apples divided by the marginal product of labor. In words, what that's saying is that if we know how much output each worker can produce, and we know the number of apples produced, and if we just divide the number of apples by how much each worker produces, then we can get back to the number of workers. Likewise, we can do the same thing with oranges. We can just divide on both sides by MPL oranges, and what we'll get is that oranges over MPL oranges, or MPLO as I'm going to write, will give us the number of workers working in oranges. So what that will give us is that L bar is going to be equal to apples over MPL of workers in apples plus oranges over MPLO. And so we've just rewritten the number of workers with the number of units of output. So you can see here that if we know the total population, we know the marginal productivity of workers in both apples and oranges, then this is going to tell us the total all of the combinations of both apples and oranges that we can achieve, subject to the fact that we just have a fixed population. Okay, and so the next slide sort of spells that out in a little bit more detail. So, so the first equation is going to be our our production possibilities frontier. As I said, it spells out, given if we know the productivities of labor and the total population here, then we can figure out what our country can produce, all the combinations of apples and oranges. But the next equation is just rewriting the above in terms of the apples, x equals apples, y equals oranges plane. So now we know here this is a function of oranges in terms of apples with a slope of negative MPL oranges over MPL of apples. And so this is going to connect closely back to what we thought about the price line, because if we think that a consumer, they're going to be limited by their income in terms of what they want to consume, well, a country is going to be limited not by its income, well, by its income, but that is true. But they're going to be limited in the case of no trade by their population and how many goods it can produce. So this is going to be very analogous, as you sort of might see, to the case of the budget constraint. And so, as I mentioned, the slope is just the ratio of the marginal products. And so what you can also think of that as is the amount of oranges that must be given up to obtain one more unit of apples, or in essence, the opportunity cost of apples. How many oranges that you must sort of discard if you want to gain one apple. So this is going to be a linear function. Our PPF is just going to look like a straight line. When there's going to be two or more factors of production, the PPF will be curved, but we'll talk a little bit more about that later. So suppose the economy has 50 total workers, and MPL of apples is 5, and MPL is oranges is 10. And then what we want to do is we want to just derive the PPF. So all we're going to do here is we're going to plug in for what we know about the population and productivities. So this is going to be 50. This is going to be apples over 5 plus oranges over 10. Okay. And so that should be what the slides tell us. Or if you just rewrite it so that you have oranges on the left-hand side and apples on the right-hand side, get oranges is equal to 500 minus 2 times apples. So drawing that PPF, well, what we get is that suppose that we produce 0 apples, then oranges is 500. But if we produce 250 apples, then oranges is 0. And so that tells us the x and y intercept, or the orange and total amount of apples that we can produce. And then notice that the slope is just going to be -2 here. Okay. And so what is the slope of the PPF representing words? Well, notice it's just saying if I want to gain 1 apple, I have to give up -2 oranges. So it represents the opportunity cost of apples in terms of oranges. And so that's what that represents. And so we'll be talking a lot about this later, especially a lot more in section 2. But that, for now, is what I want to say about production possibility frontiers.